Hey, this is a tutorial to go over Workbook 11.2 where we're going to be looking at maximum, minimums, and end behaviors within our Algebra 2 class. So before we begin, we are going to be discussing these vocabulary words as they apply to math. So they're going to be defined maybe a little bit differently than the way that we would use them, just in a normal conversation. So I would always encourage you to look at these key terms. So I opened up those key terms in a separate tab here. And as you can see, there's a lot of vocabulary. Some of them you're probably like, oh yeah, we just use that word all the time now in math class. But I want to focus on the maximum and minimum. And in fact, they say relative maximum and minimums here. And so they define them as, in this case, the relative maximum, the highest output of the function within a relatively small interval. So we're looking at a piece of the graph. That interval is like a piece of the graph, and we're looking for the highest point. So the minimum would just be the smallest output within that piece of the graph or within a relatively small interval. Oops, I don't need that. Thank you. So what does that mean? So if we were to look at this cubic function, so first, this is a cubic function. It's different than a quadratic because the end behavior, well, because it's a different degree, but then also a big characteristic change is that the end behaviors are different. Here we can have an end behavior. See, this guy is going down, so at the end it's going down, and at this end it's going up. Those arrows indicate that they're going down or up forever and ever and ever and ever. So if we're going up forever and ever and ever and ever, we're never going to have an absolute maximum, because as soon as you think you're at the highest point, it just continues to go up higher and higher and higher. And then same thing with the minimum. So we can't have absolute max and mins, because again, they're going up and down forever and ever and ever. So instead, we say, hey, let's focus on an interval. Let's focus on a piece of the graph. So if I were just to focus on this piece right here, then I can kind of hone in and say, hey, I see two little humpity humps. I see a hump here where I can think to myself like, oh, that's probably going to be a maximum. This is a minimum. And to describe those maximums and minimums, we say a relative maximum and minimum. They're not absolutes because, again, they go up and up and up forever, down and down and down forever. So relative to kind of this piece that we're looking at, I have a maximum and a minimum here. So that, I think, is like a tricky wording if we were to look at within this workbook. So we keep on going through different examples of how to identify those different maximums and minimums. So looking at this graph here on the left, the pink one, we again are looking at just a piece of the graph and saying, okay, within this little interval, where can we see a maximum and a minimum? Well, we can see a maximum at this point. So I would say I have a maximum value at 0.6. We're always looking at the y's because maximums, we're looking at how tall something is, right? So we measure tall in the y values. So minimum is at this negative 2.1. Now here down below, we're looking at what's called interval notation, and what this is doing is that it's describing what the graph is doing. The graph rises. So remember, we read graphs from left to right. So if I were to walk this graph, I'm going up in this section. So wherever x is less than negative 1.5, we'd be going up. We're going up again right here. Whereas the graph falls, so we're going down. If I were to walk this graph, I'd be heading downhill in that little section, and we describe that section to be in between negative 1.5 and 0.2. So I think that is going to help us as we look down below to our questions. So which statement is true about the function represented in this graph? Okay, so first I'm going to just kind of take inventory of this function. I can see the ends of the graph, so I can maybe describe the end behaviors of this graph. It's going down and then up. I can see a relative maximum at this 13.1. I can see a relative minimum at this negative 1.1. I can see where the graph is going up. I can see where the graph is going down and then up again, and then we can see some x-intercepts. So out of all of that information that I just gleaned from glancing at that function, which is true, and it's those relative maximums and minimums that we just highlighted. Okay, and then this one, which statement is true about the function? Okay, so we're still looking at the exact same function. That's kind of nice. So what is in... the function is decreasing. So where is it going down? I'll use red to show going down. If I were to walk this graph, remember we walk coming in from the left-hand side. Read graphs just like we read English, left to right. So where would I be going down, decreasing? Well, that's not it. I'm hiking up. So down, oops, I need my pen. It's just this little section right there. So where is that going down? Well, it's going down from negative 0.5 to 2.5. So it's between those x values. And then we can look to see that the function is increasing on those two different sections. So increasing and then increasing again. Okay, looks like the exact same graph, but just without all of those key critical points there. So this is actually describing the end behavior. So end behavior is just describing what's happening at the ends of the graph. Pen. I don't know why it keeps switching to such a large pen. Whatever. So we got this end and then this end. So what's happening on this end? So on the left-hand side, we're going down, right? So how do I describe that on the left, it's going down? Well, left and right uses x. So on that left-hand side, we say as x approaches negative infinity. So what does that mean? So if I were thinking about x's, if I'm getting close to the most negative x that there is, I'm going this way. I'm going to the left. Okay? And then how do I describe this going down? Okay, up and down describes y's. So this function, its name is f. So I'm going to say my function is going down to the y's is also approaching negative infinity. So this is what we read actually right here. As x approaches negative infinity. So that's saying, hey, on the left-hand side, f of x approaches negative infinity. So on the left-hand side, my function is going down. And then I would just flip it and reverse it to look at the upside. As x approaches positive infinity. So as x's are left and right, so as x is going to the most positive number there is, that's to the right, my function approaches positive infinity. Oh, so it's going up. So I hope that is helpful for 11.2. If you have any questions, let me know.